So, welcome to the introductory class of centroid and center of mass and center of gravity. So, what does this centroid mean? Centroid actually refers to a point within an object. So, if the geometry is simple, this centroid lies within the object, and if it becomes conjugate, we'll see in upcoming class, then the centroid might lie outside the object. That case is also possible, but we'll be seeing. So, centroid actually refers to a point within the object where we assume all the forces, all the effects considered which can take place due to the area is passing through it. Means it's a point about which effects are passing. So effects are passing. But what is the significance of this point when we try to find out the centroid? Then what does this actually mean? So in order to understand that, first we have to understand a concept called as moment of an area. So moment of an area is equivalent to moment of a force, where moment of a force is found about a point always, and moment and it is calculated as magnitude of the force multiplied by the distance, perpendicular distance between the point and the force itself. So something looks like this. If this is my force, this is my point, and this is my distance d, and we can see the force is perpendicular to the distance between the point. So that is why this is the magnitude of force. So similar to this, the moment of an area is the moment created by an area. So if I have an area which is lying at a point D, which is lying away from a point A by a distance D, then at this particular point, if moment of the force is F into D, then the moment of the area will be A into D. So A into D. This is something called as moment of an area. So practically speaking, a centroid refers to a point about which the sum of the moment of area of that particular geometry is going to be 0. I'll tell you an example. Take a piece of paper, A4 sheet mostly, and fold it diagonally or fold it about its middle axis. And then you will have the centroid of that particular geometry. And now I ask you to place your finger at that particular point, and you guys will observe that this piece of paper is balancing without any problem. So what actually happens when you place a finger? Let us suppose I have an area which is placed at a distance x. So due to this area, the system will try to get unbalanced. This area is trying to apply a movement downwards, and for this the paper will trip. And you can observe this while removing your finger from that particular point and keeping it anywhere. So if you are going to keep that finger anywhere, your paper is not going to remain at that particular position or the equilibrium condition. So, and if you place your finger right below this point, so I take an area. So it is a possibility that the area of same magnitude placed at the same distance x will counter this. So this system is trying to strip the paper like in clockwise direction, but a same area placed at the same distance on the opposite side is trying to counterbalance it. It's not like the same area is placed at the same distance is counterbalancing. There might be a possibility that a larger area placed just at a smaller distance is also counterbalance, but no one can actually tell you what thing is counterbalancing which section. But the crux is from the centroid, the sum of moment of all the area at that particular point is going to be 0, and that is the practical significance of our centroid. At the same time, a centroid is actually a position. A centroid is actually a position. Means we are trying to find the distance of that point, particular point. Okay. So when you are asked to find a centroid, remember centroid is a point which is usually found for 2D geometry. 2D geometry, it can be a triangle, it can be a square, it can be a rectangle, anything which possesses 2D geometry, means dimensions are only in two dimension, x dimension and y dimension. Okay, so position, this centroid is actually a distance. It's a location, since we are only dealing with two coordinates x and y. So this, for a centroid, the points will be always x and y, where x bar refers to the centroid of the geometry in x direction, and y bar refers to the centroid of the geometry in y direction. So centroid is for two dimension. It is the sum of moment. It is a point about which the sum of the moment of the area is going to be 0, or in general words we can express all the mass is concentrated at that particular point. Just remember this point, centroid is for two-dimensional geometry. Now the next point is center of mass or center of gravity. So it also refers to the same point. It is an imaginary point, or it is a point about which we assume that all the effects are passing. And the definition remains the same, but except since center of mass or center of gravity is found for a 3D geometry. 3D geometry means now you have a shape which is present in three mutually perpendicular direction, x, y and z. Now suppose I have a cylinder. I have this cylinder placed in the coordinate. Now we need to find out what are the coordinates of this centroid in x direction, in y direction, vertical direction, and there is a depth, means in z direction also. So 3D geometry, or I can say it is the distance. Now you need to find out three points, x bar and y bar and z bar. Now that is the only difference between the centroid and center of gravity and center of mass. Now since we are dealing with volume, the definition will modify as it is a point about which the sum of the moment of the volumes are 0. The same definition now we have applied it, means now I'm going to show you. I have a volume, I take a small volume which is placed at a distance d from any point A. So I have this volume. So the moment of the volume will be V into D, and it says that sum of the moment of all the volumes and all the distances starting from 1 to n is going to be 0. Here I can write summation of all the areas AI and all the distances DI at I is equal to 1 to n about the point centroid is going to be 0. So why do we call it center of mass and center of gravity? Remember, anything if it has a volume and volume is multiplied by the density, you get mass. So that is why it is called a center of mass, or when you multiply the center of mass with acceleration due to gravity, you get weight. So remember, if you are trying to find out the center, that point, the distance of that point using mass, you will term it as center of mass. And if you are trying to find out using the weight, you will term it as center of gravity. And that's the only difference how it is represented in this one. What is the unit of centroid and center of mass? So unit is, it's a distance, remember. So distance is, it can be, if it is SI unit, it will be meter, otherwise millimeter is also very common. Centimeter can be also there, but the thing is, whatever is the unit of the dimension is given will be the unit of your answer. So suppose if you are trying to find out centroid, your final answer will look like x bar, y bar, and if the dimensions were centimeter, you will write it centimeter. Or for centroid, it will be x bar, y bar and z bar in the same units. And this is all about your centroid and center of mass. Okay.